Norman, the math solution provider. In this video, we'll be learning about factors. So what exactly is a factor? I like to call them babies, multiplicative babies of bigger numbers. So basically, a factor of a number or of a big number are those numbers that when you divide the bigger number by them, you get a whole number without remainders. Let's take, for example, we have 20. What are the factors of 20? I like to start with 1. 1 is a factor because 1 times 20 gives us 20. Okay? 2 is a factor because 2 times 2 times 10 equals 20. And 3 is not a factor. 4 is a factor. Okay? 4 times 5 equals 20. And 5 is a factor, of course, because 5 times 4 still equals 20. 6 is not, 7 is not, 8 no, 9 no, then you have 10. And we have 10 times 2 equals 20. And then again you have 20. 20 times 1 equals 20. So the factors of 20 are, you have 1, we have 2, we have 4, 5, 10, and 20. So let's find the factors of 15. Okay? We have 1 times 15 equals 15. So we have 1. 2 can't go. We have 3 times 5 equals 15. So we have 3 here. And we still have 5 times 3 equals 15. We have 5. And we have 15 times 1 equals 15. We have 15. So these are the factors of 15. So let's find the factors of 48. Wow. We are sure of 1. 1 times 48. Times 48 equals 48. Okay? It's an even number, so 2 should go. So 2 times what? 2 times 24 equals 48. Is it divisible by 3? I guess 3 times 16 gives us 48. So we have our 3. Do we have 4? Yep. 4 times 12 gives us 48. No 5. And we have 6 times 8 equals 48. Wow. No 7. And we have 8. Do we need to write it back? We have 8 here. So pick our 8. Pick our 12. We'll pick our 16. Pick our 24. And we'll pick our 48. And, my dear friends, these are the factors of 48. Prime numbers. We'll talk about prime numbers now. So what's a prime number? A prime number is that number that has just 2 factors, 1 and the number itself. So examples of prime numbers are 2. Mind you, 1 isn't a prime number because 1 has just one factor, and it's 1. The prime number should have 2 numbers, 2 factors. They have 2, 3, 5, 7, 8 is not 9, no. 11, 13, 17, 19, and so on. Fun facts. 2 is the only even prime number we have. Yeah, just 2. Other even numbers have 2 as a factor. So now we talk about prime factors. Prime factors are those factors of a number that are prime numbers. Okay? So, let's take, for example, you have, like 20 we worked with earlier. Let's find the prime factors of 20. Okay? Remember, our prime numbers are 2, 3, 5, 7, etc. Okay? We know that 2 is a factor of 20. 3 is not, and we know 5 is a factor of 20. So basically, the other factor of 20 is 10, and 10 is not a prime factor, a prime number. So basically, these are the prime factors of 20. So you may be told to make up a number with the product of its prime factors. How do you go about it? Now let's take 20 for example. We have 20. And we're trying to get the product of its prime factors to present it as a product of its prime factors. You have 20 divided by 2. You have 10. 10 divided by 2. You have 5. And 5 divided by 5, we have 1. So we've gotten to the end of the process. So now it's 2 times 2 times 5. You can say 20 equals 2 times 2 times 5. So this is representing 20 as a product of its prime factors. So let's represent 24 as a product of its prime factors. Okay? The same way we did it earlier with 20. See, we have 24. Okay? We are sure 2 can go because it's an even number. So you have 2 divided by 2. By 24 divided by 2, you have 12. 2 can still go. 12 divided by 2, you have 6. 2 can still go. 6 divided by 2, 3. Then 3 is the next prime number that can go. So we have 24 equals 2 times 2 times 2 times 3. Sorry, it's looking a little bit clumsy. Now let's represent 60 as a product of its prime factors. I have 60. Okay? And it's an even number, so 2 can go. 60 divided by 2 gives us 30. Another even number, 2 can still go. 30 divided by 2, 15. Now it's an odd number. 1 next, 3 can go. I have 3. 15 divided by 3 gives us 5. And we have 5. 5 divided by 5 gives us 1. So we have 60 equals 2 by 2 by 3 by 5. So this is the product of its prime factors. So now, let's find out about how to find the highest common factor HCF of a given set of numbers. Okay? You might be given a set of numbers, you might be required to find the HCF of those numbers. Let's take, for example, you are told to find the HCF of 10, 15, and 20. Okay? So you're supposed to represent them as a product of its prime factors. That way, you now find out the common factors they have. Okay? So let's say 10 equals, we know 2 is there, and 5, basically. Okay? You have 15. We know 3 is there, and 5. Then you have 20. There is a 2, there is another 2, and there is 5. Let's find the HCF of 36, 48, and 72. Wow. Okay, let's try to find the prime factors of 36. Let's start like this. An easier way so that we're able to do it fast. So you have 36. It's an even number, so 2 can go. And we have 18. 18 is still an even number. 2 can go. We have 9. 9, we have 3. 3 can go. We have 3. Then 3, 1. So for 36 equals 2 times 2 times 3 times 3. So for 48, we have 2. Okay, it's an even number. So 2 goes and it's 24. Still an even number. 2 will go again and gives us 12. Still an even number. We have 6. Even number 3, then 3, 1. So 48 gives us 2 times 2 times 2 times 2 times 3. Then our 72. 72. An even number as well. 2 gives us 36. Another 2 gives us 18, 2 gives us 9, 3 gives us 3, and 3 gives us 1. So we have 72 equals 2 by 2 times 2 times 3 times 3. So we get their common factors. We have 2, 2, 2, circle them. We have another 2, 2, 2, circle them. Okay, we have 2, 3, 2, 2, no. So we can now have 3, see, 3, 3, 3, and this one goes. So at the end of the day, we have 2 times 2 times 3, which gives us 12. So 12 is the highest common factor 36, 48, and 72 have in common. I hope you learned 1 or 2 things from this video. Please look for a good maths textbook and solve as many questions as possible relating to this topic. If you have any questions, any comments, or any topic you want us to discuss, please use the comment section. Please like, share, and subscribe to my YouTube channel. Thank you.